This video is on finding the nth term of quadratic sequences. Now I will show an example and how to find the nth term of this quadratic sequence. Now the method I'm going to use is not very intuitive, but if you practice it a lot, you can get really good at it. This is how you do it. So what I want is I want a sequence in the form, or the nth term in the form an squared plus bn plus c. So the first thing I'm going to do is I'm going to try and find this a here. So let me choose the red color. So I'm trying to find the a, and this is how we're going to do it. So I look for the difference. So this is plus 9, this is plus 13, plus 17, and plus 21. So I don't have a common difference here, but in a quadratic sequence, the second, if I do the difference of the difference, that will be common. So I will have plus 4 here, plus 4 here, and plus 4 there. So the second difference is common. That's how I know this is going to be a quadratic sequence. Now to find this a, what I need to do is this second difference, I need to divide it by 2. So I'm going to do 4 divided by 2. That's going to give me 2. And this is my a. So a is 2. Okay, so that's really important. That's the first step. Now that I know a is 2, I'm going to write this part of the sequence. Okay, so I'm going to write this sequence again, and I'm going to write the sequence that represents an squared. So a is 2, so 2n squared, and I'm going to minus it from this sequence here. So let's do that now. So my original sequence is 6, 15, 28, 45, 66. Okay, and now I'm going to write the sequence for this part here. So now my a is 2, so I need to write 2n squared. So I have 2n squared. And the sequence for that, okay, so the first term would be 1 squared. So 1 times 1 times 2. So that's going to be 2. The second term is going to be 2 times 2, which is 4, times 2 is 8. So it's going to be 8. Third term, 3 times 3 is 9, times 2 is 18. Fourth term, 4 times 4 is 16, times 2 is 32. And my fifth term would be 5 times 5 is 25, times 2 is 50. So what I'm going to do now is I'm going to take away the 2n squared from my original sequence and see what that leaves me. So 6 take away 2 is 4. 15 take away 8 is 7. 28 take away 18 is 10. 45 take away 32 is 13. And 66 take away 50 is 16. Okay, so what I've done is I've taken my original sequence and I took away 2n squared. So I took away this part. So what I should be left with is bn plus c. So I'm trying to find my bn plus c now. So I'll do that in. So this is what I'm trying to find. And this part here that I worked out, this part here is the process of finding bn plus c. This was 16. Okay, so now so I know I have 2n squared. Now I need to find my bn plus c using this. So let's look for the difference here. So the difference here is plus 3. Difference here is plus 3. So I can see that I have a common difference here. And this is actually a linear sequence. So when I took away my 2n squared from my original sequence, I'm left with a linear sequence. And this is what I should expect, because I should be left with bn plus c. So the nth term for this sequence is going to be 3n. Now I can see the first term is 4. So if I have 3n, 3 times 1 is 3. And I need to add 1 to get to 4. So it's going to be 3n plus 1. Let me just check with the second term if it's correct. So 3 times 2 is 6, add 1 is 7. Let's check with the third one. 3 times 3 is 9, add 1 is 10. So this is my sequence. This is my nth term for this sequence here. So altogether, if I have the sequence 2n squared and I have the sequence 3n plus 1 and I add them, if I add these, I get my original sequence. So you can check that. So 2 add 4 gives me 6, 8 add 7 gives me 15, 18 add 10 gives me 28, and so on. So this sequence here is 3n plus 1, and if I add this to this, I get my sequence here. So my nth term for my original sequence is going to be 2n squared plus 3n plus 1. Now there's lots of steps in finding one of these nth terms, for these quadratic sequences, but what you need to do is you need to practice this lots and lots of times. So you need to practice this a lot, so get used to the method. So we found a first, looking at the second difference and dividing it by 2. So you always divide by 2 here. So if the second difference was 6, I would have done 6 divided by 2, and this would have been 3, so a would have been 3. Okay, so you always divide by 2 here. And then, now that I know my a, I write the sequence for 2n squared, and I take it away from my original sequence and see what's left. And this should be a linear sequence, and I found the nth term for that. Now I know the sequence for this, add the sequence for this, gives me my nth term for that. So the nth term for that, so this would go on and make 2n squared plus 3n plus 1 as the nth term. Okay, now here are some questions for you to try. Okay, so you need to practice all of these, and we're going to do more in the lesson. So answer these questions and bring that to the lesson.